Ukraine just captured something that Russia swore could never be taken intact. The T-90M Proryev, Russia's most advanced main battle tank, the crown jewel of Russian armored warfare, the platform that was supposed to restore Russian tank supremacy after decades of Western dominance, is now sitting in a Ukrainian facility being systematically dismantled by American military intelligence analysts. Not damaged beyond recognition, not a burned-out hull, intact, operational, complete with its classified fire control systems, its reactive armor packages, and its electronic warfare suite. By the time we are done, you will understand why this single captured tank represents a bigger intelligence coup for NATO than 100 intercepted communications. Welcome to States News. If this is your first time here, subscribe and turn on notifications because what I am about to show you is not just about one tank. This is about how a single battlefield capture can expose an entire military-industrial complex and reshape the strategic calculations of the world's largest military alliance. I am going to show you exactly what the T-90M Proryev is, why its capture is so significant, what Pentagon analysts are learning from dissecting it, and how this intelligence windfall changes NATO's understanding of Russian capabilities and vulnerabilities. We will cover the specific technologies inside this tank, the operational failures that allowed it to be captured, the strategic implications for Russian armored doctrine, and what this tells us about the broader technological gap between Russian propaganda and Russian reality. By the end, you will understand why Russia's defense ministry is more terrified of this single capture than they are of losing 100 T-90Ms in combat. Let's start with what the T-90M actually is. The T-90M Proryev, which translates to breakthrough, represents Russia's attempt to field a main battle tank that can compete with Western platforms like the American M1A2 Abrams, the German Leopard 2A7, and the British Challenger 3. It is an extensive upgrade of the base T-90 design, which itself was derived from the T-72 lineage that has formed the backbone of Soviet and Russian armored forces since the 1970s. The T-90M entered service in 2020, making it Russia's newest frontline tank design. The specifications are impressive on paper. The T-90M weighs 46 tons, substantially lighter than Western tanks, which allows for better strategic mobility but raises questions about armor protection. It is powered by a V92S2F diesel engine producing 1,130 horsepower, giving it a power-to-weight ratio of approximately 24, 5 horsepower per ton. Maximum road speed is listed at 60 kilometers per hour with an operational range of 550 kilometers. The main gun is a 2A46 M5 125mm smoothbore cannon capable of firing armor-piercing fin-stabilized discarding sabot rounds, high-explosive anti-tank rounds, and gun-launched anti-tank guided missiles designated 9mm 190mm reflex. But the real upgrades are in the electronics and protection systems. The T-90M features the Kalina fire control system, which integrates thermal imaging, laser range finding, and ballistic computation to enable first-round hit probability that Russia claims rivals Western systems. The commander's station includes a panoramic sight with thermal capability, allowing hunter-killer engagement where the commander identifies targets and hands them off to the gunner. This was a capability Western tanks had enjoyed for decades, but that Russian tanks lacked until the T-90M. The defensive suite is equally sophisticated, at least in theory. The tank is equipped with relict explosive reactive armor, an advanced generation that is supposed to defeat tandem charge warheads by using a double-layer explosive sandwich that disrupts both the precursor charge and the main penetrator. The Shtora-1 soft-kill active protection system uses infrared jammers and laser warning receivers to disrupt incoming anti-tank guided missiles. There is also a hard-kill active protection system called Arena, though its integration on production T-90Ms has been inconsistent. This is the tank that Russia showcased in military parades, that defense ministry officials claimed would dominate any battlefield, that state media described as impervious to Western anti-tank weapons. And now one is sitting in a secure facility where American engineers are photographing every component, testing every system, and cataloging every vulnerability. The capture occurred in Ukraine's Kharkiv region during localized counteroffensive operations in March 2024. Ukrainian forces from the 92nd Mechanized Brigade engaged a Russian armored column that was attempting to reinforce positions near Kupiansk. The engagement involved a combination of drone-dropped munitions, artillery strikes, and direct fire from Ukrainian armor. The Russian column became disorganized. Crews abandoned vehicles. Most of the abandoned tanks were destroyed by subsequent artillery, but Ukrainian forces secured one T-90M before Russian forces could destroy it or recover it. What made this particular capture so valuable was not just that the tank was intact, but that it was captured so quickly that the crew did not have time to implement destruction protocols. Russian doctrine requires crews to destroy sensitive equipment before abandoning vehicles. This includes the fire control computer, the radio encryption modules, and ideally the entire vehicle through internal charges. The crew that abandoned this T-90M either panicked, were injured, or were killed before they could complete those procedures. The result is that Ukraine captured the tank with its systems intact. Within 72 hours, the tank was transported to a secure Ukrainian facility. Within a week, American military intelligence personnel were on site. The Pentagon moved fast because they understood the intelligence value. Russia produces only a limited number of T-90Ms annually. Estimates range from 60 to 90 tanks per year. The total number in service is probably fewer than 500. This is not a mass production platform. This is Russia's elite tank, deployed only to frontline units. Having access to an intact example is extraordinarily rare. Now let's talk about what Pentagon analysts are finding. The first priority was mapping the fire control system. The Kalina system integrates multiple sensors and computers to calculate firing solutions. American engineers extracted the software, documented the hardware architecture, and tested the actual performance against claimed specifications. What they found was a mix of genuine capability and significant limitations. The thermal imaging system is reasonably effective, using French-origin Catherine FC thermal camera technology that Russia acquired before sanctions were tightened. The image quality is inferior to American third-generation thermal systems, but better than older Russian systems. The ballistic computer is competent but lacks the processing power of Western equivalents, meaning calculation times are slightly longer. The real weakness is in the integration. Western fire control systems like those on the M1A2 Abrams use distributed architecture where multiple computers share data across high-speed networks. The Kalina system uses more centralized processing, which creates single points of failure. If the main fire control computer is damaged, the gunner loses most advanced targeting capability. On Western tanks, redundant systems allow degraded operation even after component failures. The T-90M lacks that resilience. The active protection systems revealed even more significant problems. The Shtora-1 infrared jammer is designed to disrupt older anti-tank guided missiles that use infrared guidance. It is completely ineffective against modern Western missiles like the Javelin, which use imaging infrared seekers that cannot be jammed by the Shtora's relatively simple modulation. The system is fighting the last war, designed to counter 1980s technology rather than current threats. The Arena hard kill system, which is supposed to intercept incoming projectiles with a shotgun-like blast of fragments, was installed but not fully integrated. Analysts found that the radar warning system was connected, but the automated intercept function was disabled, apparently due to reliability concerns. The crew would have to manually activate intercept, which is essentially useless in combat. The relict reactive armor blocks were removed and subjected to ballistic testing. Pentagon analysts used shaped charge warheads similar to those used in Javelin and TOW missiles. The results were mixed. Against older single-charge warheads, relict performs as advertised, disrupting the penetrator jet effectively. Against modern tandem-charge warheads, which fire a precursor charge to detonate the reactive armor followed by the main charge, relict provides only partial protection. The double-layer explosive design does disrupt the main penetrator to some degree, but not enough to prevent penetration against the base armor underneath. This confirmed what battlefield evidence had suggested. Javelin missiles are killing T-90Ms despite their advanced armor. The most significant finding concerned the armor itself. The T-90M's turret uses a combination of steel, composite materials, and ceramic inserts designed to resist armor-piercing penetrators. American analysts conducted metallurgical analysis and armor penetration testing. What they found was that the actual protection levels are substantially below Russian claims. The stated frontal armor protection equivalent is supposed to be 800-900 millimeters against kinetic penetrators. Actual testing suggests effective protection is closer to 650-700 millimeters. This is still respectable, but it means that modern Western tank guns firing advanced penetrators can defeat T-90M frontal armor at combat ranges. The implications of this are significant. Russian tank doctrine assumes that the T-90M can survive frontal engagements with Western tanks at typical combat distances of 2,000 to 3,000 meters. If the frontal armor is weaker than claimed, Russian tanks need to engage from longer ranges where their inferior fire control systems put them at a disadvantage, or they need to avoid frontal engagements entirely, which is tactically limiting. NATO armor commanders now know that their main battle tanks have a decisive advantage in frontal engagements. This knowledge changes how they will employ armor in any potential conflict with Russia. The engine and drivetrain analysis revealed reliability issues. The V92S2F diesel engine is a proven design with roots going back to Soviet-era development, but the specific variant used in the T90M has had quality control problems. American engineers found evidence of substandard manufacturing in several components. Piston rings showed premature wear patterns. Fuel injectors had inconsistent spray patterns. These are not catastrophic failures, but they indicate that production quality is not meeting design specifications. This likely reflects sanctions' impact on Russia's access to precision manufacturing equipment and high-quality steel alloys. The transmission, a long-standing weakness in Russian tank designs, showed improvement over earlier models but still lagged behind Western standards. Gear engagement was rougher, shift times were longer, and the overall mechanical efficiency was lower. This translates to higher fuel consumption and increased maintenance requirements compared to Western tanks. In sustained operations, these small inefficiencies accumulate into significant operational limitations. Pentagon analysts also examined the crew ergonomics and found that Russian design philosophy remains fundamentally different from Western approaches. The T-90M uses an autoloader for the main gun, eliminating the need for a dedicated loader crewman and allowing a three-man crew instead of the four-man crews in most Western tanks. This saves weight and reduces the size of the vehicle, but it creates limitations. The autoloader can only accommodate 22 ready rounds in the carousel. Additional ammunition is stored in the hull, and reloading the autoloader carousel during combat is slow and dangerous. Western tanks with human loaders can sustain higher rates of fire for longer periods. The crew compartment is cramped by Western standards. The driver operates in a semi-reclined position in the hull. The gunner and commander sit in the turret with limited space for movement. This is acceptable for short missions but creates fatigue during extended operations. Western tanks prioritize crew comfort because fatigued crews perform worse in combat. Russian design prioritizes smaller vehicle size. There are legitimate arguments for both approaches, but the practical effect is that T-90M crews are more likely to experience performance degradation during long engagements. Now let's step back and talk about what this means strategically. The intelligence gained from one captured tank affects multiple dimensions of military planning. First, it allows NATO to develop more effective tactics for defeating T-90Ms. Knowing the exact performance envelope of the fire control system tells NATO commanders at what ranges and under what conditions Western tanks have advantages. Knowing the weaknesses in the active protection systems tells infantry anti-tank teams which weapons are most effective. Knowing the armor protection levels allows for more accurate mission planning regarding ammunition loads and engagement ranges. Second, it allows NATO to assess Russian military-industrial capability more accurately. The quality control issues in the engine components, the incomplete integration of the hard-kill active protection system, and the actual armor protection levels all suggest that Russian manufacturing is struggling to meet design specifications. This is critical intelligence for long-term planning. If Russia cannot build tanks to their own specifications now, what will their capability be in 5 years after continued sanctions and brain drain? The answer appears to be declining capability, which changes the risk assessment for NATO expansion and forward deployment decisions. Third, it affects arms sales and international perception. Russia markets the T-90 series to countries like India, Algeria, and Iraq. The T-90M is supposed to be the premium version that justifies premium pricing. If international customers learn that the actual performance is substantially below claimed specifications, it damages Russia's credibility as an arms exporter. Countries that were considering purchasing T-90Ms might opt for Chinese alternatives or upgrade existing platforms instead. This has economic consequences for Russia's defense industry and strategic consequences for Russia's relationships with client states. Fourth, it provides technological intelligence that goes beyond the tank itself. The thermal cameras, the laser rangefinders, the ballistic computers, all of these components reveal the current state of Russian microelectronics and precision optics manufacturing. Pentagon analysts can assess whether Russia is developing these technologies domestically or relying on imported components that sanctions should have blocked. If they find Western or Chinese components that were imported despite export controls, it identifies sanctions evasion channels that can be closed. Let me show you how this played out in a specific case. The fire control computer in the captured T-90M contained microprocessors that were manufactured in Taiwan by a company that is supposed to comply with U.S. export restrictions. The chips were not cutting-edge, they were several generations old, but they were not supposed to be exported to Russia. The discovery triggered an investigation that identified the smuggling route. The chips were being shipped to shell companies in Kazakhstan and Armenia, then transshipped to Russia. U.S. Treasury officials worked with Taiwanese authorities to shut down that channel. One captured tank led to closing a sanctions evasion network that was likely supplying components for thousands of Russian military systems. There are complications and limitations we need to acknowledge. The T-90M that Ukraine captured may not be perfectly representative of all T-90Ms in Russian service. Production quality varies. Early production vehicles may have different specifications than later ones. It is possible that the specific tank captured had manufacturing defects or component failures that are not typical. Pentagon analysts are aware of this limitation and are careful not to overgeneralize from a single example. But even with that caveat, the intelligence value is immense. One data point is infinitely better than 0 data points. Additionally, Russia is aware that NATO has the tank and will assume that its secrets are compromised. This may accelerate Russian efforts to field improved versions or different platforms. The T-14 Armata was supposed to be Russia's next-generation tank, but production has been delayed and limited due to cost and technical problems. The capture of the T-90M may push Russia to prioritize Armata production, even if it means accepting higher costs and continued technical issues. Alternatively, Russia may focus on asymmetric responses like increased use of anti-tank guided missiles, loitering munitions, and mines, rather than trying to compete in tank versus tank engagements. We should also recognize that tank technology is only one dimension of armored warfare. Tactics, training, maintenance, and combined arms coordination matter as much as the technical specifications of individual platforms. Ukrainian forces have destroyed Russian armor through superior tactics, even when the Russian vehicles had technical advantages. The capture of one T-90M does not mean NATO would automatically win every armored engagement, but it does mean NATO has better information to develop winning tactics. There is one more angle that deserves attention: the psychological impact on Russian forces. Russian tank crews know that a T-90M was captured intact. They know that NATO now understands the vulnerabilities of their most advanced tank. This knowledge affects morale. If you are a Russian tank commander, you were told that the T-90M gives you the best chance of surviving combat. Now you know that NATO has blueprints for how to kill you. That creates doubt. Doubt affects decision-making. Tank commanders who doubt their vehicle's protection are more likely to hesitate, to avoid aggressive maneuvers, to prioritize survival over mission accomplishment. This erosion of confidence is a second-order effect that is hard to quantify but strategically significant. The intelligence value extends beyond immediate tactical applications. Pentagon analysts are using data from the captured T-90M to inform future weapons development. Understanding how Russian fire control systems operate informs design of electronic warfare systems that can jam or spoof them. Understanding armor composition informs development of next-generation penetrators for American tank guns and anti-tank missiles. Understanding weak points in the design informs targeting doctrine for American tankers and infantry anti-tank teams. The knowledge gained from this one tank will influence American weapons development for the next decade. There is also an industrial intelligence dimension. The manufacturing quality issues discovered in the T-90M components provide insight into Russian defense industrial capability under sanctions. Pentagon analysts can assess which technologies Russia can still manufacture domestically and which require imported components. They can identify which sanctions are working and which are being evaded. They can predict how Russian military capability will degrade over time as sanctions bite deeper and manufacturing quality declines further. Consider the geopolitical signaling value. The fact that Ukraine captured a T-90M and allowed American analysts access demonstrates the depth of U.S.-Ukraine intelligence cooperation. It signals to Russia that Ukraine is not fighting alone but has the full backing of American intelligence and technical expertise. It signals to American allies that sharing intelligence with Ukraine produces valuable returns. It signals to potential American partners that cooperation with the U.S. military provides access to cutting-edge intelligence that can dramatically improve their own military capability. The capture also affects Russian export prospects more broadly than just the T-90 series. Countries considering purchasing Russian weapon systems now know that if those systems are captured in combat, their secrets will be compromised to NATO. This creates reluctance to buy Russian systems for countries that want to maintain some independence from NATO, but do not want their military capabilities fully transparent to Western intelligence. India, for example, operates substantial Russian equipment but also seeks to maintain strategic autonomy. The T-90M capture makes Russian equipment less attractive because it comes with the risk of intelligence compromise. Let's talk about the timeline for intelligence exploitation. The initial assessment of the captured tank took approximately 4 weeks. Pentagon analysts photographed and documented every system, tested basic functionality, and identified priority areas for deeper analysis. The next phase involved destructive testing of armor samples, electronic reverse engineering of the fire control system, and metallurgical analysis of engine components. This phase took 3 to 4 months. The final phase involves integrating all findings into comprehensive intelligence reports, updating threat assessments, and distributing information to relevant military units. This final phase is ongoing and will continue for another 6 months. By the end of the full exploitation cycle, the Pentagon will have produced detailed technical manuals on every aspect of the T-90M. These manuals will be distributed to armor officers, anti-tank specialists, electronic warfare experts, and intelligence analysts throughout the U.S. military and allied forces. Every NATO tanker will know exactly where to aim to penetrate T-90M armor. Every anti-tank team will know which weapons are most effective and at what ranges. Every electronic warfare operator will know how to jam or deceive T-90M sensors. This comprehensive knowledge distribution multiplies the value of the single captured tank across the entire NATO alliance. Russia is aware that this intelligence exploitation is occurring and has attempted damage control. Russian state media initially denied that a T-90M had been captured, claiming that only older T-90A models had been lost. When photographic evidence made that denial untenable, Russian officials claimed that the captured tank had been sabotaged and its critical systems destroyed before capture. Pentagon analysts found this claim to be false. The systems were intact. Russian military leadership then attempted to downplay the significance, claiming that the T-90M in Ukrainian hands was an export variant with downgraded systems. This is also false. Analysis of the fire control computer and other components confirms that the captured tank is a Russian military variant, identical to those in frontline service. These Russian denials and distortions demonstrate how seriously the Kremlin views the intelligence compromise. If the capture were not significant, they would not bother lying about it. The fact that they have constructed multiple layers of false narrative indicates that they understand the strategic damage. They are trying to minimize the psychological impact on their own forces and the political impact internationally. So where does this go from here? Pentagon analysts will continue studying the captured T-90M for months. Every system will be tested to failure.